Welcome to Group 19's design of a supercapacitor base torch. I am M.L Woodhead.
I'm Matare.
I'm K.D Naidoo.
I am presenting the charging indicator circuit, which makes use of an op-amp comparator, which will be powered by a constant 5 volt supply. The supercapacitor will be plugged into the plus side of the op-amp comparator, while the negative side or the minus side will contain the voltage divider. The voltage divider is set at 2.6 volts and makes use of a 24K resistor and 26K resistor. While charging, the red LED will be on constantly. When 2.6 volts is met, the green LED turns on and the red LED turns off. Charging of the supercapacitor takes about 1 minute and 44 seconds, and it takes about 38 minutes to discharge from full brightness of the torch.
To have a supercapacitor-based torch, we need to power LEDs. Our LEDs are rated about 3.5 volts each. Here lies the problem because we only have a supercap that has 2.7 volts, so we need to create a circuit to boost that voltage up. The circuit is right here. It's called the boost converter circuit. It has 4 major components: an inductor, a MOSFET, a diode, and a capacitor. The diode is preferably a Schottky diode. That way it has a lower forward voltage and has more time to recover, therefore better efficiency. The inductor should preferably be a larger toroid. That way the current has more time before it actually saturates. The values for your inductor and your capacitor can be found using these 2 equations right here. And the load over here will be our LEDs.
For the boost converter circuit to work, we need to switch the MOSFET on and off. And to do that, we are using a square wave in form of a PWM from an Arduino. The square wave is a frequency of 100 kilohertz and a duty cycle of between 42 and 78% at full brightness. The duty cycle is calculated using this, and the relationship between the V out, voltage output, and duty cycle is that. When the supercapacitor starts to discharge, the output voltage will decrease. Therefore, a feedback loop is put in place that will read the output voltage to the Arduino, and the Arduino will adjust the duty cycle accordingly to keep the output voltage constant. At half power, appropriate duty cycle was calculated and set.
The supercapacitor is being charged by a bench supply set at 30 volts and 6 amps. The supercapacitor is currently at 2.39 volts and the red LED is on as it is under 2.6 volts. As you can see now, the supercapacitor is currently charging. As you can see, now the green LED is on at 2.62 volts, and now the supercapacitor can be used anywhere else.
This is our final design and implementation of our supercapacitor-based torch. For portability, we used an old recycled box. To charge the capacitor, we have suicide doors implemented. And we have 2 functionalities, a red switch and a white switch. Red switch switches the circuit on and off, and the white switch changes brightness levels.